All right, the first one says to simplify. So to do that, I want you to have out that table that we created on Monday, and I want you to find the fourth row. So the nth root is 4. I'm going to find right now, so everybody's looking at their table, is 243. Is 243 in the fourth column of your table? Is 3? Is 48? The answer to all of those should be no. So what you're going to do is, this is going to be your helpful hint, is you're going to take this number 3 and you are going to divide it into 243 and you're going to divide it into 48 to see if we have a realization. So I would take 243, you have a calculator, divide it by 3. What do you have for an answer? 81, correct? Now go back and look in that fourth column because the nth root is 4. Do you see 81 there? Okay, good thing. So we're going to take this and I'm going to break down 243 into the fourth root of 81 and the fourth root of 3. Okay, please take 48 and also divide it by 3. Take 48 and divide it by 3. Your answer is 16. Is 16 in that column? Okay. Break this apart. Fourth root of 16 and fourth root of 3. Okay, so I'm going to change colors here so we can see the different steps. I'm going to bring down the 5. And what is the fourth root of 81? It's on the chart. Fourth root of 81, look at your chart, is what? 3. And then we have fourth root of 3. Now I'm going to bring down this middle term, which I haven't used yet. And I'm going to bring down the 2. So plus 2. And the fourth root of 16 is 2. Okay, my next step is going to be to multiply anything in front of the fourth root of 3. 5 times 3 is 15, so 15 fourth roots of 3, minus 9 fourth roots of 3, plus 4 fourth roots of 3. Now there's different ways to explain this, and the way that I'm going to continue to explain is not like some marvelous mathematical way. I just found in past years, students get a little confused here. Do you see how each one of the 3 terms contains a fourth root of 3? So I'm going to make up just any symbol, like, let's actually use star. And I'm going to say star equals fourth root of 3. So wherever I see a fourth root of 3, I'm going to replace it with star. So this is 15 star minus 9 star plus 4 star. So stars are kind of like x's. 15x minus 9x plus 4x. If I told you to combine like terms, you'd go 15 star minus 9 star is 6 star. And 6 star plus 4 star is 10 star. But really, there's not a star in this problem. Really, what is star? It is fourth root of 3. Final answer. Okay, let's look at the 1. Again, you're going to have to write this down. Or if you don't want to write it down, you're welcome just to follow along by watching. That is also perfectly fine. So please look into the third column. Does 16, because the nth root is 3, does 16 exist in the third column? No. Does 2 exist? Does 1024 exist? So let's take the smallest number, 2. Can you please divide 16 by 2? Obviously, you can do that in your head. You get an answer of 8. Does 8 exist in that column? It does. So we're going to break this apart into the third root of 8 times the third root of 2. Please take 1024 and divide it by 2. The answer is, what is it?
512.
Is 512 in the third column? You're answering for me. You're looking at your column.
Yes.
It is. Okay. So 512, third root of 512, and the cube root of 2. Same steps here. Okay, now I'm going to go back, and I'm going to bring down this 15. So 15, and I know the cube root of 8 is 2. I'm going to bring down the subtract 8, cube root of 2, and bring down the plus 2. Can you please tell me what is the cube root of 512? I don't have that one memorized. Look at your chart. It is 8. Thank you. Now I'm going to multiply numbers that exist in front of the cube root of 2. 30, cube root of 2, minus 8, cube root of 2, plus 16, cube root of 2. Again, the next step I'm going to do, I have found is helpful for students in the past. It's not required for you to do, though. So I'm going to say that star is equal to the cube root of 2. 30 star minus 8 star plus 16 star. Okay, 30 subtract 8 is 22 star. And 22 star plus 16 star is what? 38 star? And really it's not a star, it is actually 38 times the cube root of 2. So that type of problem of simplifying, can I have a thumbs up to the side or down based on your understanding? High enough where I can see where I'm currently seated. Thumbs up, to the side or down. We are going to have more practices with those tomorrow. Most of us are to the side or up. Okay, does this problem exist right now in your notes? It does. Okay. Whenever you are solving, you always have to be aware of extraneous solutions. And we talked about those first semester. That means you do all of the math correctly, but when you get an answer and you check by plugging it back in, it doesn't always work out. Extraneous solutions mean you do the work right, but when you check it, it doesn't work out, so you can't consider it as a solution. All right, so here we go. I'm going to put a line down the center here. I'm going to try to write small. I'm going to start, it's not required, but I think it's easier for students when you're first solving. I'm going to start by rewriting. And what is the nth root here that I don't see in this problem? So I'm going to rewrite this, and I'm going to rewrite it in exponent, rational exponent form. Remember, when you solve, you're actually doing like PEMDAS going backwards. So we're going to start from the very bottom. We're trying to solve for m. And remember, you can't consider the operations inside the parentheses as adding or subtracting tasks. So the first thing is PEMDAS, going all the way down, starting at the bottom. So parentheses, exponents, multiplying, divide, add, subtract. Is there any adding or subtracting on the outside to get rid of? And there is. So let's subtract 231 from both sides. You do have to show all the steps here. So I've taken care of adding and subtracting. Is there any multiplying to get rid of? And there is. We are currently multiplying negative 1/4 times this quantity. So I'm going to put brackets around what already exists. And I'm going to multiply the left and right by the reciprocal, which is negative 4 or negative 4 over 1. By doing so, the 1's and the negative 4's, bless you, the 1's and the negative 4's are going to cross cancel. But remember, when they cancel, they don't turn into zeros. They turn into what number? 1. No longer affecting the problem. Multiplying, you have negative 16 over 1, which is negative 16. Okay, moving on up here. So I've taken care of adding, subtracting, multiplying. We're on to exponents. So this is new for some of you. If you want to get rid of the 1/2, just like we did reciprocals here, we're going to raise this to the reciprocal power. The reciprocal of 1/2 is 2 over 1. Also, you could just say 2. 2 over 1 is the same as 2. So raise it to the second power on both the left and the right. The 1/2 and the 2 are going to cancel, remember, turning into 1's. And negative 16, you have to make sure you keep it in parentheses. If you keep negative 16 in parentheses and you square it, you end up with 256. Subtract 56 from both sides. 5m equals 200. Divide by 5, and m equals 40. Now we have to go back and make sure this works out. Please grab your calculator. You're going to do the steps with me. So I have an answer of 40. I'm going to start by doing what's inside of the radical. So I'm going to do, let's do second square root. Please do that. Second square root. And we hit the second key in order to find the radical. And then I have 5 times 40. And it is plus 56. Then press enter. So I have an answer of 16. Now I need to multiply it by the negative 1/4 that's out front. Let's keep it in parentheses. And the final step is to add 231. And what answer do I want to get? If this works, what answer should I get? 235. But do I get 235? So what does that mean? It means this is an extraneous solution, and rather than writing the whole words out, I do capital E, capital S, representing extraneous solutions. So if somebody said to you, what's this answer? You'd have to say no solution, because the one answer you came up with was extraneous. Let's go on right now. Please find this next problem. I believe this problem is also on your notes. Am I correct? Okay, so I'm going to rewrite it in rational exponent form. Not required. I just think initially some students find it easier to do. Okay, we want to start by getting rid of the exponent, the 1/2. So just like in the previous problem, to get rid of the 1/2, I'm going to do brackets on both sides, and I'm going to raise it to the reciprocal, which is 2/1, also known as 2. The 1/2 and the 2 as the exponents, they multiply, and they actually reduce just to a 1, or cancel out as most of you think of it. And here's the biggest mistake students make. Most students say when they evaluate this portion, they get 2x squared. Remember that 2 applies to the 2 and to the x. So 2 squared is 4, and x squared is x squared. I'm going to move everything on the left to the right because the right has the x squared. Remember, when you move it across the equal sign, it changes signs. So 4x squared changes signs to positive 5x, changes signs to a negative 6. Okay, I'm going to do bottoms up. What multiplies to equal negative 24 and combines to give you positive 5? The answer would be what? Positive 8 and negative 3. Don't forget to do bottoms up. So when we solve here, we end up with x equals negative 2 and x equals positive 3/4. Now, first I'm going to show you how to get the answer, how do we check, and then we're going to talk about some common sense with math. Let's start off with negative 2. Come up to the original problem, we're checking for extraneous solutions. So this is a pretty easy problem. If you plug in negative 2, negative 5 times negative 2 is positive 10. And positive 10 plus 6 is 16. The square root of 16 is 4. But when you plug negative 2 in for the right, 2 times negative 2 is... So a lot of students say, when I said, does this make sense? They're like, yep, that's right. 4 equals negative 4. That works. If you looked into your checking account, would there be a difference between having $4 in your account versus negative $4? So these are not the same things. That means we're going to go down below to negative 2. We're going to put a line through it and write extraneous solutions. Now let's talk common sense. This is a square root. It's what you're used to working with prior to this unit. So square roots always give you an answer of 0 or anything positive. Let's do it really quick. Are you ready? Grab your calculator. We know the square root of 0 is 0, right? We know the square root of 1 is 1. Just do a couple. Square root of 2. Do you still get a positive number? Square root of 3. Do you still get a positive number? Don't take time to do this, but the square root of like 98,000, would you still get a positive number? So whenever you take a square root, the key is I'm saying square, not necessarily a cube root. Whenever you take a square root, you're going to have 0 or a positive number. Well, let's look here. So when I plug in the negative 2, that means this answer would have to be positive, right? But if I took the negative 2 and I substitute here, what is this going to give you? A negative. So here we didn't even have to do the work. You can use common sense to say, hey, I know this is going to be positive, but when I substitute a negative 2, I know it's going to be negative, and a positive number is not the same as a negative. Okay, we're going to now substitute in 3/4. We're going to do this with the calculator. So ready? Let's do square root, and it is 6 subtract 5, and in parentheses, was it a positive 3/4, I think, right? So 3 divided by 4, and then we'll press enter. We have 1.5. So the left-hand side is 1.5. Now on the right-hand side, it's 2 times 3/4, and we also get an answer of 1.5. So we checked. And in this case, if somebody said to you, what is the answer to this problem? It would only be 3/4, not -2. I believe this problem is also in your notes right here. Am I correct? Okay. So as you go through this, you're going to learn that when you see a problem like this that has a radical on the left and a radical on the right, nothing extra. So there's not like a +3 behind this or a 2 in front. When they have the same nth root, we actually just get to cancel the radicals. But that's something you're going to realize as time goes on. For now, let's rewrite this in rational exponent form. If I told you you wanted to cancel out the 1/3, what would you raise it to? Okay, let's do to the third power on both sides. The 1/3 and the 3's cancel. Remember, they're really turning into 1s. And now we can solve. And again, you can move things to the left or right, keeping with the right math rules and still get the right answer. Okay, so let's check. 2 times -9 is -18. -18 plus 5 is -3. So the left-hand side is -3 raised to the 1/3. Now I'm going to take -9 and plug it into the right. 5 times -9 is -45. -45 plus 32 is -13 raised to the 1/3. So I don't even need to go to the process of raising these to both to the 1/3 because I can see the left side equals the right side. Correct answer is -9. Am I correct? Those are the only problems you have on your worksheet?